Test, Test. Hallo Soundmann.
Den Bild ist keine Option.
Nee.
Hast du den Talk noch heute nicht bekommen?
Ich saß den ganzen Tag dran, ja. Ich hatte keine Zeit mehr für Design.
Hallo, hallo?
Wenn jemand im Publikum boot, dann weißt du Bescheid.
Ja.
Fangen wir an, oder? Setzen. Macht's euch gemütlich. Es ist eine schöne kleine Runde. Ja, schönen guten Abend. Hallo zusammen. Schön, dass ihr alle da seid. Willkommen bei StudiTemps. Vielleicht ganz kurz, weil Pascal hat gesagt, ich soll ein paar Worte erzählen, auch so ein bisschen, was macht StudiTemps eigentlich? Also vorneweg wollte ich fragen, haben wir Englische oder Englisch? Should we switch to English? All right. Is it okay? I can try it in English. It's okay for you. All right. Welcome to StudiTemps. Yeah, Pascal asked me to say a few words about us and what we are doing. StudiTemps, we're doing temping, so temporary jobs for and with students. So basically we bring students into jobs while they are studying in university. And we're doing that for like the last 10 years, and what we especially in the product and development department are doing is we develop software to support the entire business. And our goal is to digitize the entire business that we're doing. So yes, and while doing that, we are working on different platforms. We're building software with Ruby and with Elixir and a lot of frameworks, front-end stuff. And we also started to write a mobile app, I think in last year already. And that was the first try, and we were playing around with like hybrid technologies, and it didn't work out really well. We failed, I must say. And so this year we tried it again. We staffed a completely new team, and we wanted to start with React Native. And we had to learn that writing mobile applications is quite complex, especially in software systems that are distributed, like ours. Like we have a lot of different tools that communicate with each other, and yeah, our mobile app had to connect with everything. And yeah, still we're kind of struggling. Why do I tell you that? That's because, you know, if you're interested in help us, you know, in writing our mobile app, you might come to me after that talk, and we discuss, you know, about some job opportunities. That was a bit silly, sorry for that, but now I want to start introducing Pascal. Yeah, we were very lucky to get to know Pascal, Pascal Welsch. He's a Google developer expert and I think a super Flutter expert. And yeah, you all heard of Flutter, and he wants to explain us everything about declarative UI today, so that we hopefully understand it. You know, so yeah, thank you very much for being here, and have fun with Pascal.
Thank you. That was a well-prepared talk. Those are not mine. Okay, is the camera fine? Or does it need adjustment? No. Okay, let's start with declarative UI. I might be a bit biased today because I'm a Flutter developer expert, and this talk today is not about Flutter. Yes, I will include Flutter because I think Flutter today is one of the amazing tech which is out there, especially if you're building mobile apps. And I personally would write almost every app today with Flutter. Let's talk a bit about myself. I'm a freelancer. I've become self-employed a short time ago, and I'm also a coach and a speaker. What I mean by coach and speaker is I gave workshops about Flutter. So if you are interested about learning more about Flutter, if you think, oh yes, I should definitely write my new app in Flutter, but I don't have that much experience, come to me and I will give you a workshop and a great introduction into Flutter. Not only a Hello World example, but I really want you to learn how you can build Flutter in a bigger team and professionally. I started as an Android developer and I love building client-side applications. But at some point I realized building Android is really, really hard. And actually I have better ideas to spend my time than working on Android UI. And at some point I said, I don't want to work on Android UI anymore. There are other tools out there which makes it much more easier to build UIs, to build the same thing, and I don't need 2 weeks, I need 2 hours. And that's why I completely stopped building Android UIs with the Android tools. Instead, I built Android apps with Flutter. So just that you know my background. And at the beginning, I want you to tell this story about a blue button. This is not a true story. I made it completely up. But it should show you what could happen if you are building mobile applications or building user interfaces in general when you are under time pressure. And let's see how it goes. So you get a user story because we all work in Scrum, Kanban, all those cool stuff. You get a user story, and at some point, yeah, please color this button, this checkout button in blue. People have trouble finding it. It's better if it's in blue. No problem. You implement it in blue. And please think about it. How would you implement this? And not in a real good way. Think about the client comes in, hey, please change the color to blue. I want to show it in 1 hour to at a pitch at somewhere. Please change it in 1 hour. It has to be blue. Please fix it. Okay, you do it. You change the color to blue. No problem. And the next thing is, so maybe this time you have a bit more time, and the checkout button should be gray. Normal gray, because it's disabled when the phone is in airplane mode. And this is something which happens a lot. You get requests like that, not because the user who created this issue knows that airplane mode is only one case where the phone has no internet, but anyways, you implement it like that. You listen for airplane mode, is it on or off, and depending on that, you change the color from blue to gray. Easy. Next, user story. And this is something which is very common right now in mobile apps. In Android and iOS, both operating system introduced the dark mode. And you have a lot of time implementing the dark mode, and everything is defined in a sketch file. You get a sketch file, and you start implementing the dark mode. No problem, it works. You never get any complaints. You have now your app in dark mode and in light mode, and it just works. And this goes on for months and months. And suddenly, you get the first bug with this button. How is this possible? And it turns out somebody noticed that if he's in the dark mode and he's toggling the flight mode, the button somehow became blue, which doesn't fit in the design. It should be red. But suddenly, it is blue. How is this possible? And it's not understandable for the client, but you as developers, you might understand this. Because the fix you introduce to change the color to blue, or to change the color, to switch the color when the flight mode toggles, might not be perfect. And I want to show you an example how this might look like. So this is a piece of code. I totally made this up, but I've seen code like that. It's just a broadcast receiver in Android. You receive information from the Android system. For example, in this time, you can check if the airplane mode is on or off. And every time the airplane mode changes, you get a callback and you can check is the airplane mode on and off, and you change the color of the button because that is what the ticket says in the beginning. And you change it to gray or to blue. It's fine, it worked. But here is the bug. This logic here doesn't care about the dark mode at all. It was written in a time where there was no dark mode, but this code might still exist at a time where a dark mode added. And also the feature of toggling the button when the airplane mode switch, this might not be checked by QA in dark mode and in light mode. Maybe QA only cares about light mode and expect the dark mode to work at all. There are so many variables, and usually code like this doesn't handle all those variables. So how could this code look like if we do it with a declarative UI. And yeah, first of all, what is a declarative UI? Before I talk about declarative UI, I have to show you what is imperative programming. And imperative programming is using statements to change the program state. So you write statements to change the state. Like in the case before, you wrote a statement to change the color of a button. That's code you actually wrote, and that's imperative. And I wrote over years, I wrote imperative-styled UIs. And they worked, but at some point I learned this is not the way to go anymore. Instead, what I really want is declarative programming. And this is, you describe what you want to show, and the framework handles it for you. You only tell if there is dark mode and the airplane mode is off, show the color gray. That's all you said. You never actually touch the button and update the color. You only tell what should be shown at certain conditions. And this is an example, also totally made up, how this could be solved. So instead of, I still receive the event from the operating system in the onReceive method, and I check the airplane mode, but instead of changing the color of the button, I change my app state. And the app state is something abstract. It's an in-memory state, and there is all the state of my application. It might not be a single variable. It might be a state of a single screen, whatever. But here it's the app state, and the app state has a property which is called has internet access. And when I change this has internet access property, my UI starts to re-render. And this render method should be called every time something of the app state changes. And when the render method is called, I get the app state as a parameter, and that's all information I have. It should be a pure function. So this function here should not have any side effects. It should only describe what to show in the UI. That's why I'm not actually updating any button here. I only return something which is called a widget. And the widget is only a description of what should be shown in the UI. And in this case, it's a button widget. It has a text, and depending on the app state, it shows different colors which depend on the app state of internet access and dark theme. Inside of this function, all cases are handled. You as developer are forced to describe all cases. If you don't describe all cases, you have to return something at some point. So you have to decide what to show at any point of that app state. After this function returns and gives you the description of what should be shown in the UI, some other framework, which might not be written by you, can update the whole UI and can only do minor updates. So this is one way to solve this, but I will go into more detail later on. The whole idea is that the UI, the rendered UI, is only given that you have an app state, put it in a function, and it returns the UI. And this should be possible for every app state. So every time something changes, this function will run and updates the UI, and you always get a new UI. Yes, we have questions. For questions, please use the microphone.
Hallo, könnt ihr mich hören? Sorry, I didn't want to interrupt. I wanted to ask if it's even possible to do questioning in between.
Sure.
Okay, thank you. I was wondering what app states can be. It seems to me a bit abstract for now because I'm not a professional developer. Yeah. So what I was expecting is you said offline mode, like airplane mode. That's an app state. So the app itself. App state
could be anything. It could be the items in my to-do list. It could be if a button is visible or not, if a dialog is shown or not. All state you require to render the screen. So if you look at any screen, you can think about what do I need to have for data to show this screen. So if you think about a to-do list, you obviously need the items in the to-do list. You need the state of those items. Are they checked or not?
But the airplane example is a situation from outside the app. Because
yeah, but the app, I go back. The airplane mode, that's why I added this receive method. With this receive method, I get information from the system if something changes.
So it could be
and
also
then I save it again in my app state.
Okay, so it could be even the brightness is below 20%.
Yes.
Oh,
yeah.
Okay, thank you.
Anything you can imagine.
All right, thank you.
Another question?
Yes, you showed this example. Is this dependent on some particular language?
No, I totally made this up. This is a mix of multiple UI frameworks.
Okay. I wanted to ask if it's really, if it's always embedded in the code, or is it possible to separate the UI from the code? For example, when I want to give the UI part to someone that does UI, but can't really program.
Yeah, you can definitely separate it, and you should separate it. I didn't do it for this example. This is not compiling code. I totally made it up. Yeah.
Okay, sorry.
Okay, now I've shown you an example what declarative UI could mean. I want to show you where declarative UI comes from. As I told you, most of the UI I wrote the last 10 years was imperative styled UI. And I did it with JavaScript, with Flash, which was great, and also with Android. And I always did imperative UI. But declarative UI existed a long time ago, even longer than I'm doing programming. So the first time I really got to know declarative UI was with Microsoft WPF, which was part of the .NET framework. And at that time, I think it was 2006 when it came out, it was pretty good. I mean, this was the code you have written before. You did everything in code. You wrote your text widgets, and you created all of that. And then suddenly they introduced XAML. And XAML, you could, instead of writing this code, you could write that code. And it's really cool, and it helped a lot to see what's actually going on the screen. Additionally, they added an UI editor, so you can drag and drop things, whatever. In the end, it looked like that, and the adoption was pretty good. The problem with that is, so if I go here, all of that is static. There are no click actions. It doesn't listen to any data. So what they did is they called this code behind. So additionally to your XML file or your XAML file, you added another C# file with code behind. So for example, if the button clicks, this function here runs. And they are linked with each other. There's only one way, so you get data out of the XAML file. It also works the other way around. It can listen to models and view models and reacts to changes. But one thing it doesn't do is removing elements. So you still have your static XML, and it displays a static UI. And you load it once and show it, but if you want to remove an item, you have to write this in C# code. There's no way to hide an item depending on some UI. You really have to write code to imperative remove items or update items. If you're coming from the web, you might know handlebars, which is basically the same like XAML, but for the web. At the top, you can see some template file, which is using a model to show some data. And at the bottom, you see actually this context thing here. This is just a data structure, and all the data are consumed by the template, and then you can render that template and you get out HTML. And this is actually pretty good because you can render it multiple times, and you can change the data, render it again, show it, and it's always the correct state. It's more or less a pure function. You give in the context here, and you get out HTML. And you can do it for every change. It's pretty good, but that's not the end of what declarative UI actually is. Next, there was Angular, which is super popular in the web before React. So what Angular did is this cool thing here. It looks super confusing, and it's two-way data binding. So basically, you have a model in the middle, and you have also the template file on the one side and the output, the view on the other side. And both are listening to the model, and both are updating the model. And it's super confusing, and the biggest problem with Angular nowadays is the performance. At some point, your model gets really big, and you have tons of views, and everyone is listening to the same thing. And if you update one thing, hundreds, thousands of callbacks are fired to update stuff. And this is really a problem with two-way binding. And then there came React.js. And I still remember that in 2013, I was sitting, I didn't watch the live stream when they introduced React.js, but I watched it a few weeks later. And I watched it and I was like, wow, this is great. And I show you why. So before, it was always like, yeah, you render your UI initially, and then you mutate your UI depending on the changes. So you listen to all the changes and you update your UI. That's how it was for a long time. And the question Facebook asked themselves is like, wouldn't it be simpler if we could avoid the mutation of the UI? Because this is actually where all the bugs are from. And yeah, this is how it works. Every time the app changes, you are not mutating your UI, you are rendering the whole UI from scratch, everything. And with that, it's totally simple. All the code you write is just one function which returns HTML. And it's super easy to test, and this is how it should go. The only problem, and that's why nobody ever tried this before, is performance. Removing all the elements from the DOM and adding all the elements again is pretty harsh. And if you imagine a text field somewhere, and you remove that from the DOM and add it again, your cursor might be at the wrong position, data might be lost, so that's definitely not the way to go. But they did a clever trick, and this is called virtual DOM. So at the top you can see the DOM, where all the elements are shown which are displayed, and on the right, on the left, are the models. So the models are rendered to a DOM. And if you would remove the DOM and add all nodes, it would be more or less the same. But this is very expensive. Instead, they rendered those things into a virtual DOM, basically the same representation, and then they do clever diffing. They diff between what's currently shown and what is the update. But back then, I was still an Android developer. This was nothing which would come any time soon. How does React.js look like? So basically, you have a function, and you get in properties, and you return HTML. That's more or less the example I showed you in the beginning. And you render it to the DOM. And you can do this every time something changes. Of course, you can write components and things like that. It's pretty modular, but this is the whole concept. Nothing different than what I showed you before. The big difference compared to Angular is that it's a one-way data binding. So you get data, and you always update your model, and the model re-renders that thing. Whereas in two-way data binding, everyone is listening to everything, and everyone can change everything. It's a mess. I want to talk quickly about pure functions. And if you are familiar with other languages like Elixir, for example, pure functions, or functional programming in general, they love pure functions, and in some languages it's the only way you can use functions. Basically, you have a function, you get two input parameters, which could be any kind of properties, and you return something based on that parameters. And then the function is pure, because the function itself doesn't talk to external things. An impure function, on the other hand, would be something like that. You get an account and an amount, and then you work with that data, and you mutate some of that data. That's impure. you should not change the data which are coming in. You should not talk to external sources, like to a singleton within your function. And if you are writing pure functions, it makes the thing very testable. And we will come to that later on. In React, all components, so all the UI things you are writing, they expect it to be pure functions. There are lint checks which help you to do this, because you can break it, but the framework expects you to write pure functions to work properly. And this is what I mean. This paradigm here only works with pure functions. If your function here talks to other things other than state, it doesn't work very well. Then it's not testable anymore. Then at some point, now I know React, and I'm still working in an Android app which has an imperative style. I became frustrated, and then I saw Flutter. Until then, I only knew about React. I never tried it. And Flutter was the first framework where I started to look deeper in React, because Flutter itself is very React inspired. They use the same terms. There are sometimes the same language, method names you are calling. These frameworks are very close together, with the only difference: React runs in the web and Flutter runs everywhere. Another cool thing about Flutter, so if you haven't heard or checked Flutter out yet, is that it's very well made for developers. So in the web, for a long time, you had something like a hot reload. You change something in your code and it's automatically visible in the browser. As a mobile developer, I never had that. I had to wait minutes to see my changes on the screen. And then came Flutter, and suddenly I could change something in my code, hit save, and it was instantly visible on my device. And this alone made me switch to Flutter. I mean, the time to develop something decreased dramatically, because I change something, I see it on the screen. I break something, if I do something wrong, I see it on the screen as a red thing, and then I fix it and it's visible again. I don't have to restart my app. So only a side note, why Flutter is super amazing. As I already said, Flutter is React style framework, and at that time it was for Android and iOS. In the meantime, it works for far more platforms. I can write Flutter apps for my Mac. I can write Flutter apps for Windows, for Linux, for embedded system like a Raspberry Pi. You can write an app just for the Raspberry Pi and it runs natively on it. And recently, it came back to the web, which is pretty amazing. You can now write Flutter apps for the web. The big difference compared to other tools like React Native, which claim to be the same thing, is the Skia rendering engine. Flutter comes from the Chrome team. People of the Chrome team started with the Flutter project. And they thought, now we have this cool rendering engine inside of Chrome, which is called Skia. What if we could just ignore that there are things like HTML and CSS and write a cool UI framework only for Skia, completely ignoring all the web standards. And what came out is Flutter. So Flutter is basically all the cool things from the browser without the legacy stuff like HTML and CSS. How does it look like? If you've seen React, this is very similar to what React looks like. The main difference is that Flutter has no JSX. So these div elements don't exist. Instead, they have other widgets. For example, a column, a text, a raised button. You will not see any HTML elements here, like button, select, whatever. They simply don't exist, because all Flutter does is it gives you a super great abstraction of drawing to a canvas, whereas React gives you a cool tool to build a HTML site. Flutter gives you a great tool, or is a great tool, to build code which renders on a canvas. And that's all it does. Yeah.
I wanted to ask something. You said that all other frameworks render to HTML. There's this expression in German, it walks together nothing. So it's basically you say that there needs to be declarative UI framework in the browser, that there's no always this fuck. Eigentlich ist es so gut. Aber auch genauso wie das halt, das im Prinzip die ganze Erklärung zum Jetpack gemacht wird und auch nach dem Angular, der auch immer eigentlich nur das anzeigen möchte, damit eigentlich nur die Bilder anzeigen. Eigentlich müsste man das die ganze Zeit so machen, Flutter einfach das UI im Browser präsent und sagen, mach mal.
That's an interesting question. Yeah, I will repeat it. So why are other frameworks in the browser are still using HTML to render stuff, whereas you actually just want to paint on a canvas to show the same stuff? And the main reason why you always want to have HTML in the browser is because there are other tools which rely on HTML. For example, search engines. And you don't want to have a web page which draws on a canvas and displays all the text there because it cannot be indexed by search engines. And so you want to have the plain HTML. And other things like accessibility, you want to have HTML labels for that. But on mobile, we can ignore it because there is no app indexing, at least not in the way it works in the web. So we can just draw on a canvas, the same for all desktop operating systems. Another interesting thing is here, there is no templating. So in XAML, you were using this XML style thing. In web, you were using this DOM thing or this HTML text. Here you write pure code. Column text and raise buttons are just constructors. And they are constructors to construct widgets. In this example, every time something changes, so you get a callback if the button is pressed, you call setState to change the state of your whole widget. And here it increases the counter, and this magic setState function, as in React, re-renders that widget. So whenever setState is called, the build function is executed again, and it returns the new UI, which should be displayed then. And this is what I mean with more or less pure functions. This function only returns what should be displayed on the screen. It is declarative because it's very well readable for humans. Every one of you understands this is a column and it shows a text at the top and a button at the bottom. It's super readable, more or less the same as with other languages like XML. There is one thing, if you dig a bit deeper into Flutter, at some point you will notice all the examples I see, the build method gets huge. It really gets huge and it gets really hard to read. I mean, this example is still easy, but you are right, at some point it gets confusing. But it's not the fault of the Flutter framework. It's actually your fault. And this is my personal tip for you as a developer, especially if you start with Flutter. If your build method gets too big, it's not Flutter's fault, it's your fault. You should split your method into multiple methods. Treat it like it was normal code. You don't write long methods in your normal business logic code. You shouldn't write long methods in your Flutter code. So treat it as code, extract methods, extract variables, and suddenly it's very well written code, easy to read. Only because you can write everything in one build functions, you shouldn't. I want to show you a timeline here when all the things came out. And you might notice if you started here with Android development and you ended here at some point in 2016, you get a bit frustrated because at the bottom for the mobile frameworks, there were no big framework releases. Whereas the web in the meantime had Angular, React, Vue.js, you are still stuck with the Vue code which was written in 2006. And this really frustrated me, and that's why I really looked deep into inside Flutter, which came out back then. And yeah.
Why didn't you look into Qt?
Because I tried it, and at the time when I tried it, I think it was 2013, something like that. It was still beta for Android and still not working for iOS, and they had scaling issues and things like that, and it wasn't great, and I still was able to build better apps with what I had in Android. And later I never looked into it because it's C++.
That I understand. The Android support was a bit steady, a bit rocky. I used it about half a year ago, and the support is now much better. But I forgot that you wanted to your main target is Android apps. So if that's the case,
Android apps wasn't good, and right now.
Currently,
I would say Flutter is the better alternative to Qt on all platforms.
If you want to depend on this particular language, that's true. But if you don't want to write in what was the language, Kotlin or what was it?
For Flutter, it's Dart.
Yeah. So if you don't want to write apps in Dart, you can use any language with Qt because it doesn't depend on anything. And even it runs on more platforms than Flutter, probably.
Definitely not. But we will can talk later about this. So the thing I want to show you here, nothing happened on the mobile side. That's why I switched to Flutter. Right now, there is something happening on the mobile side as well. There is SwiftUI and Jetpack Compose. SwiftUI, a declarative UI framework for iOS and Mac applications, and Jetpack Compose, the equivalent on the Android side for all Android platforms. Let's talk about them and dig a bit deeper what they provide. So SwiftUI is actually really interesting. It has 4 years of internal development, and one reason why it wasn't announced earlier is that they required hard changes in Swift, and basically the DSL feature, which is still not merged into Swift, is the core of what SwiftUI builds on. And so they couldn't release earlier, but they could have been ready. So they had a really long development time, and if you try SwiftUI today, it's a really good tool. They claim on the website, and if you try that they have something cool as hot reload for Flutter, where you can just type in your changes and see it on the device. It doesn't work like that. You cannot see it on the device. You can only see it in Xcode for some limited things. So if you're just building UI, you can see it in Xcode. If your UI depends on external data, you cannot see it in Xcode. So it's not the same thing, although they claim to be the same thing. This is how SwiftUI looks like, and if you ask me, it definitely looks better than everything we have in Flutter right now. It's pretty clean, easy to read, and all of that is because of the DSL language feature. And I wish to have the same thing with Dart. If we compare this to Jetpack Compose is a joke right now, really. It was announced at Google I/O. They worked less than a year on it, and they basically released it because the same thing was released in Swift, and somehow they have to say, yeah, we are doing the same thing. But it's not ready yet. There is not even a preview release. You get the source code, but it's far from production ready. They have a scrolling container, but they don't support lists and things like that. It's really not ready anytime soon. So expect it to be ready in 2 to 3 years. One interesting fact about Jetpack Compose is that it's heavily inspired by Flutter. So Google is a big company, and they have different teams. They have a Flutter team, they have an Android team. And until like 1 or 2 years ago, they never talked to each other, which is pretty funny. This year at I/O, when they announced Jetpack Compose, I actually talked to some engineers, and the time before Google I/O, when I talked to them, I always find it funny that the Android developers there are somewhat interested into Flutter. They know the terms when I talk to them about, but they never showed much interest. This time at I/O, after they released it, they were like, yeah, we use Flutter and it's great, but we have to build the same thing for Android as well, because Flutter is a different engine. If you want to build a pure Android app, you should use a language which runs on that system natively. And I totally understand it. They want to bring the best user experience or the best tech stack to native Android developers as well. And they worked closely with the Flutter team this time. And in the source code right now, you can even see comments which were just copy-pasted from the Flutter source to the Jetpack Compose source. There are even code examples which are still written in Dart instead of in Kotlin. It's super funny. Yeah. Under the hood, both work a bit differently, but I will show you that later. This is how it looks like. Not much difference to SwiftUI. And it works more or less the same. Notice here that there's no setState method. And the reason for that is that Swift Compose and Jetpack Compose and SwiftUI heavily rely on compiler features. So when the compiler reads this, it actually detects, oh, it accesses something, the count value here, and the count is part of the state. So if this accesses it here at the bottom and connects to this, it should re-render when it changes. So the compiler does all the stuff which in Flutter and React you are calling setState to change the state. In SwiftUI and in Jetpack Compose, the compiler detects something changes, something subscribes, and at compile time, it connects those features together. So it looks really good, but there is magic under the hood. If there is ever a bug, you as normal developers are definitely unable to solve it because you are not compiler developers. What bugs me about mobile development is, other than just writing UI with an outdated framework, is testing. If you want to test a mobile app even today, it's really hard. Most of the tests you have to write as tests which actually run on a device, or you have to start an emulator to run it on that operating system, and they are also really slow. On Android, we have bigger problems with the emulators which simply don't work, or the devices which are flaky. On iOS, the tests are just slow. Writing UI tests on iOS are really slow. I think they are like 5 or 10 times slower than on Android. So with a virtual DOM, if you have some component which displays the DOM but is not rendering it to any UI, it should be really easy to test it because you are not talking to an external system anymore. You create your virtual DOM and you can run tests on that. So it's pretty easy. So how does this work with all those frameworks? With all those web frameworks, it is no problem. With Flutter, when I started with Flutter, this was another key feature which convinced me that Flutter is really, really, really good. Because I could write unit tests for drag and drop. And I definitely cannot do this for Android and iOS, at least not that simple. With SwiftUI, this is super interesting. If you're Googling right now for SwiftUI testing, you will not find anything. I think there's one article which describes that you can create your UI in SwiftUI, render it on the device, and then write the same UI tests you're currently writing for your iOS applications, because under the hood it is still using the same UI components to render the stuff. So the virtual tree doesn't exist in SwiftUI, and it doesn't help you when testing. The same is true with Jetpack Compose, and if you ask developers right now, yeah, once Jetpack Compose is finished, there will be testing support. But by now, I know if Android developers, they're saying there's testing support, they actually mean, yes, you can run it on an Android emulator and you will run those UI tests you can run right now with Espresso. And this is not what I understand as a unit test or a UI test. I want to run unit tests, thousands in a second. And this is not possible with SwiftUI and Jetpack Compose right now, and will not be possible with Jetpack Compose in a long time. The biggest problem here is, as I said, the compiler connects all those things. If something changes and someone is listening to that, the compiler detects this. This means if the complete code is compiled, you will not see that there is such a declarative framework somewhere. It really strips out the declarative framework and the virtual DOM and leaves you with code which is super performant, but you can only test it as good as you would do it right now with the code you write. Oh, there's the slide for this. Yes, the reason why they are doing this hard work in the compiler is because they want even better performance. And I've seen some graphs which actually prove that the performance is better than what you get with Flutter. But I get 60, 120 FPS with Flutter. I don't have performance problems right now. And I have this cool feature that I can write amazing tests for it. So for me, I don't need the performance. Give me better testing support. Let's talk about animations. If you're a client-side developer, you're not doing it to show tables of data. You want to build cool animations because this is what you are paid for. If you just want to have standard UI with lists and columns, you can get this for free today. But if you're building stunning animations, stunning user interfaces, especially if you hire someone to design your app, you want to have those cool animations. And with Flutter, you can build those animations frame by frame. And this is actually how I worked, even back then with Flash. When I created a cool animation with Flash, I decreased the speed of the animation so far that I can see any frame of the animation, every step of this animation. And this is how I work today when I build animations with Flutter. And the reason how this works is, before we heard, anytime your data changes, you render the UI from scratch. And Flutter goes even further. Flutter, yeah, so this is how Flutter goes. Flutter says, every time your data changes, it renders the UI from scratch, but also animations. If something slightly changes in the UI, it re-renders. It renders every screen. Your build method gets called every frame. And if we compare this to the web, in the web, if you Google today for how do I do animations with Vue.js or with React, it's pretty simple. You create your template and you use those cool attributes like with Vue if, and if an element is showing or if the state is showing, that's a Boolean property here. If it's true, it's in the DOM. If it's false, it's out of the DOM. And then you add CSS to fade it. Cool, you're using another language to fade it. That's not really what I expect from a modern framework, to rely on that old UI. Because with Flutter, you can do all that in one language in code. Yeah, so when you build a widget or when you animate something with Flutter, your build method gets called every frame. Unlike the web, you render it once, you remove the element, and then the DOM somehow animates that change. So there's a bit of magic going on. Not with Flutter. You see that your code is executed every frame. And this gives you even the opportunity to write tests for those animations. In the framework itself, there are tests for opacity animations. So if you create or if you push a new screen, on Android there's this cool animation where the new page slides in from the bottom and becomes visible. And there are tests, so if it's half slided, it should be half transparent, things like that. And I've never seen a single test in the web about opacity at a certain point in time, really. How does this work? This is a lot of code, and you don't have to read it all, only 2 things. So we have an init state method, which is called when that widget is created in the beginning, or it is hung inside of the view tree. And we have a build method here at the bottom. In the init state method, first of all, you have to say, yeah, this widget should be animatable at all. That's why you need an animation controller. This animation controller is connected with a vsync. And this vsync thing connects it to the phone's frame rate. This means whenever the phone hits a new frame, you get notified here, and you can change something. You can add this listener, and here I say, I call set state. I don't put data in there. I just say set state. I want my build method to render again. So at every frame, if that animation is running, I call this method again, and here I can read the value of that animation. Usually it's a float between 0 and 1, and I can multiply it by 200. So this container here increases its size from 100 to 300. And I think this is not hard to read, and imagine if you want to extend this animation a lot. You have some value between 1 and 0. You can do basically anything with that. You can say only in a certain interval of that 0 to 1, I want to run a certain animation and then another part in another animation. It is super flexible. How does this work in SwiftUI? It is much more, or it is much less code. This is only a part of that, and it's hard to read because I had to do a screenshot from a presentation from WWDC. And what it does is more or less the same. Right now I said it's an interval between 0 and 1. This is more or less true here. There's a property is active, which is a Boolean. And if you change that property from is active from true to false, you switch between 0.1 and 1. And this is where the magic of SwiftUI comes in. SwiftUI knows if I do this animation, I interpolate between 0.1 and 1, and it runs the animation of that thing. So there is some interpolation possible. You can do some effects, but usually you will see code like this. Very simple. It interpolates between 2 values if another property changes. It's really easy to write, and you can get stunning animations in more or less 0 code. Of course, you can do the same with Flutter. It's a bit more code. So in this thing here, it's a complete screen of an app. It doesn't have a controller. Instead, it has an animated opacity. And you can also see here, there is, if it's visible, it's 1.0, and if it's not visible, it's 0.0. And it interpolates between those values automatically in the background. The only thing is, in Swift, I've never seen a way to instantiate an animation controller and do my real custom animations. I'm always relying on the framework to interpolate between the values. Maybe that's just a lack of my knowledge, but I haven't found a way to really customize things. I can use everything which is in SwiftUI built in, and there's tons of stuff for animation, for animating UI, but I don't feel that flexible right now. Now is the real question. So you are a developer today, you have an application, maybe a mobile application, and you want to have declarative UI, which makes it easier to write tests. How can you start? With SwiftUI, just do it. It's still in beta, but it's rather good. Maybe there are some quirks in it, but you can just use SwiftUI. With Jetpack Compose, you definitely should wait a long time. And if I would still be an Android developer, that would really frustrate me. So how can you start today with building declarative UI? And as I told before, just do it by having a unidirectional data flow. So instead of changing widgets or UI components in your app, change your app state and listen to changes and render it again. It's the same process. Change the app state, notify that something has changed, render again, only depending on the app state. This again, the function, so it's a pure function and all code you write is inside of that function to update the UI. So you return an arbitrary data model which represents your UI, and then you have another function which does all the updates, which filters for, there's this button widget, it binds to that view right now, it has those properties, so I set those properties one by one. And do this for every change. It might sound that it's too complex to do those updates, but if you have used other things like data binding on Android, the same thing exists for iOS, they are actually doing exactly that. You have some way of some data which represents a button with all its properties, you have the real button in the UI, and it checks every property for every change, should I update or not. This is also how it works in Flutter. There is a component which sits on the screen, which draws that thing, which is mutable, but the framework will do all those calls to update that thing. So you can build it yourself. There are no libraries worth mentioning which are doing this, but you can do this yourself. And this is an example of how you can test those things, because it's so easy. So this is not a testing framework which exists. This is just me writing plain code. And so I create a screen. The screen has a render method and accepts an app state. So I create an app state called screen render, and I get some data back, some widget, and I can do assertions on it. And here I first add a state where the internet access is true, which is the airplane mode, internet access is false, I see another background of that button, and then I add the internet access to true again, and I see the button again in the good state, red for the dark theme. If you know your framework very well, you don't have to write all those steps, because if you have a pure function, if the render functions is very pure, you don't have to change to toggle between those states. You can just render a single state and you know exactly that state will be rendered on the screen, no matter what. It's a pure function, it will always work that way, there's no mutation going on. So here's the question, should you switch to Declarative UI? And if you haven't checked it out yet, yes, definitely. It's a standard in the web. There are basically no frameworks out there except for Angular, which are not using React frameworks. And it will be a standard with Jetpack Compose and SwiftUI in the future for native mobile development. And I know it's hard. Changing the mindset from imperative code to declarative code is really hard, and it took me months. I was very interested in that, and I spent hours on it just to learn it. It was really hard to get another perspective on how to develop UIs. But once I knew that, I was basically rendering every frame. I have to define how every frame looks like, how every pixel on the screen looks like inside my build function. It really made a click after a few months. The coolest thing right now is that you only have to learn it once. So it doesn't really matter if you are a React developer, a SwiftUI developer. If you're coming to a new framework or a new language, which also has declarative UI, you can just write it. It was absolutely no pain for me to write SwiftUI. It's easy. I know how Flutter works. Writing SwiftUI is only a slight adaptation. And with Jetpack Compose, you saw the slide before, it looks very similar, it will be the same thing. Here, because I'm not sure how the audience is distributed between different types of developers, some recommendations what you should do next. If you're an iOS developer, check out SwiftUI. If you're an Android developer, check out React or start with Flutter and see how amazing development could be. And in a few years, you can switch to Jetpack Compose. If you're a front-end web developer, you already know everything. If clients ask me if I can work with their team together, I always ask what's the background of the team members. And sometimes they are like, we have only 1 native developers and 2 are ex-web developers. I'm like, yeah, no problem. If we do it in Flutter, the web developers are actually more advanced and easier to get started with Flutter than this 1 native developer. So it's super easy for you if you already have done React. Just try out Flutter and you can have a whole new world by building mobile apps. And backend developers who never touched UI, try it. It's fun, and yeah, with Flutter you can also enter a new world. Thank you very much for listening.
So, are there any, first of all, thank you very much. I think I kind of understood now, finally, thank you. And I know that we might have to switch to Flutter for our app now. Are there any questions from your audience? Any more questions?
Has Björn another question?
Please. No? If not, then I would say we meet at the, at our Mensa, drink another beer together. Maybe we have some pizza left over, I don't know. But yeah, feel invited, and thank you again very much, Pascal. Thank you.
Thank you.